Okay, here's number 29, and A is just, they want you to graph the absolute value of 3x plus 2. There's a couple ways to do this. You could take just the line, 3x plus 2, and we know that the intercept is going to be at 2, 3x plus 2. Remember the y equals mx plus b form, so it's going to cross the axis at 2, and the slope's going to be 3, so these are kind of my interval. These are my units 1, 2, 3, 4, 5. So my slope's going to be 3, so I go up 1, 2, 3 over 1. And then there's my line, y equals 3x plus 2. And remember the absolute value whenever it's negative, and that's the value, that's the y, which is the vertical position. That's the same thing as g of x. Okay, it's functional notation. That's the vertical position. Whenever the vertical position or the value of y is negative, I have to take its opposite. So I just kind of flip that above the x-axis wherever it's negative. So right over here, the line, instead of going down, goes up. So we could graph it like that. And you could figure out the intercept when y is 0. I subtract 2 from both sides, so it's negative 2/3. That's one way to do it. Another way to do it is we could just kind of know the absolute value. We know what the absolute value of x equals, I hope. That's one of our parent functions. And we're going to talk about those a little bit later and have you do more graphing from the parent functions. But we know that this one here, y equals the absolute value of x, is just a regular v. I hope you remember that. Y and x. And the slope is 1 or negative 1, so here it goes like this, and then it goes like this. And the slope here is 1, and here the slope is negative 1 because I'm just taking the opposite, because the line would go down like this, and then we just flip it over. So if we look at this function, this parent function, if we try to get this in this form, y equals, and I've got the absolute value of 3x plus 2, then if we just want to have just an x here in our parent function form, what I can do is I can just factor or divide a 3 out. And remember, it's the absolute value. Well, the absolute value of 3 is just 3, so I can put that out like this. And if I divide that by 3, I get x. And if I divide that by 3, I get plus 2/3. So this 3 makes my v a little skinnier. And then it's shifted over 2/3 to the left. So basically, this is what we have. You see, it's shifted 2/3 to the left. And it's a little skinnier v, so that's another way to figure it out. And the slope is 3. That basically is the slope of this. This slope is 1. Here the slope, or plus or minus 1. Here's plus or minus 3. So that's another way to do it. So there's a couple ways to do that. The other one, this is a function over here. We want to graph this one here, the h of x equals x, the absolute value of x times x minus 1. Well, basically, I could take a look at this, and I could multiply this out, and I realize I'm going to have a parabola. And if I set each of these equal to 0, I can find the intercepts. It's going to be shaped like a U, and the intercepts are going to be at 0 and at 1. I can set this equal to 0. I get x equals 0. Set this equal to 0. X equals 1. So these are going to be the intercepts. It's just a parabola, normally shaped like that. Except I'm going to take the absolute value. So again, wherever it's below the x-axis, that's where the value is negative, I have to take its opposite, so I just flip it. So it looks like this, and then when here it gets to be negative, or below the x-axis, I just flip it on the top, so it looks like that. And here it's positive, so it stays positive. So again, that's not too hard to figure out, and those are absolute value functions. Okay, hope that makes sense. And we'll do some more of those a little bit later. We're going to be doing a lot of graphing of parent functions with shifts and even absolute values.